Here's a case study on transformations. This is a large online media company. The objective here was for this large online media company to transform media event data. So think of multimedia, songs, videos, those types of things. The context here was that they ingested and captured a large amount of event information. For example, if this was a song, they captured data on how long a song was played and over different behaviors that occurred. For example, if a song was played 1 second, it would capture that data, and then 10 seconds after. So for example, played n seconds, played 1 second, and then played 10 seconds, played 20 seconds, 30 seconds, etc. until the song ended. And all of this event information was captured in order to better understand how consumers were listening to songs and what kind of behavior they were displaying, whether they were listening to the entire song, whether they were listening to some part of that song, or whether they began listening to the song and after 1 or 2 seconds decided it wasn't the right song for them. In any case, there was a lot of transformations that needed to occur on this data before deeper analytics were done on this large amount of data. One of the more typical transformations they needed to do was, if there's more than one event that occurred, they wanted to exclude the initial played 1 second event because it would have been double counting. They just wanted to capture the every 10 seconds played events. If there was not more than one event, then they wanted to include that played 1 second event because it gave them insight into the number of times a consumer actually initiated a song, as an example. So this was all very valuable data. They needed to transform this. They needed to do it very quickly. In the past, they leveraged regular SQL, and this took many lines of code. It was extremely complex and tedious. Required multiple complex self-joins, joins onto each other, and it resulted in very suboptimal performance. We worked with this customer, this online media customer, and worked with them to develop an algorithm via our own nPath SQL-MapReduce function. So nPath provides sequential pattern analysis that actually looks at patterns over a single pass of data, and it goes through and ingests a large amount of data. It can be invoked within SQL on nCluster, and it's significantly simpler code. The benefits that this customer was able to gain was that using nPath, they were able to significantly reduce the amount of code from 40 plus lines of code and reduce it by 80%. So it was significantly simpler code. They were also able to go through a single pass of data and run nPath in parallel across multiple nodes in a distributed compute environment, thus cutting down cycle time tremendously, while not compromising on the deep insights that they needed in order to really understand behaviors and execute the transformation.